Hey, what's up, guys? My name is Jeffro Vargas, and today I'm going to present you some physics problems. Please like and subscribe to my YouTube channel if you learn anything physics related. And start things off, let's first move on to the first problem, which is problem 9.13 from my physics book. Now, turntable rotates with a constant 2.50 rad per second squared angular acceleration. After 4.15 seconds, it has rotated through an angle of 61.0 rad. Now, what was the angular velocity of the wheel at the beginning of the 4.15 interval? So, the ones highlighted in bold are the given, and the ones you're trying to find is initial angular velocity. So, as we stated, the given is angular acceleration is 2.5 rad per second squared, and theta is 61 rad with time is equals to 4.15 seconds. Now, the equation we're gonna use, theta is equals to velocity initial times time plus 1 half at squared. Now, we're gonna use this equation since we can plug in every variable given except for the ones we're trying to find. So, if we plug it in, 61.0 rad is equals to 4.15 angular velocity plus 1 half 2.50 times 4.15 squared seconds. So, you get 21.5 if you compute for 1 half 2.50 times 4.15 squared. So put that on the other side of the equation and you're left with 61 minus 21.5 is equals to 4.15 initial velocity. Now remove divide 4.15 on both sides and you get the initial velocity, which is 9.51 rad per second. Now the next problem. A wheel of diameter of 20.0 cm starts from rest and rotates with a constant angular acceleration of 3.50 rad per second squared. Compute the radial acceleration of the point on the rim the instant the wheel completes its second revolution. So what we're trying to find is radial acceleration, the point of the rim, which is denoted by a rad. Now you have to use the relationship angular velocity squared times r and tangential velocity over r. Now, what we're gonna do is put the given in. So we're given 20 centimeter diameter, which when we convert it to radius is just 10 centimeter radius, and we have an angular acceleration of 3.50 rad per second squared. It's at the second revolution. One revolution is 2 pi. So it's 4 pi. Next, what you need to consider. So we're trying to find, first things first, we have to find angular velocity. So to find angular velocity using acceleration and theta, which is the distance traveled, we need to use this equation. Now, it started from rest, so you can basically just remove the initial velocity squared because you don't really need it in this one. Now, our theta is 4 pi. Our acceleration is 3.50 rad per second squared. Just plug it in. Works. Angular velocity, final angular velocity squared is equals to 0 plus 2.2 times 3.5 times 4 pi, which is simply 87.96 rad per second squared. Now, what we do here is rad squared second squared because it's velocity squared. Now, what we do here is we plug that in. So, as we know, a rad is equals to final velocity squared times r. So what we do here is just plug it in. 87.96 times 0.10, you get 8.79 meters per second squared. Now, to verify this answer, we're gonna use the second equation. So linear speed is equals to angular velocity times r. So we already have angular velocity squared, which is 87.96 rad per second. Square root that and we get angular velocity is equals to 9.38 rad per second. Now v is equals to 9.93 meters per second, since that's simply 9.38 times 0.10. So v squared is equals to 0.879. So what we do here is, since the relationship given was v squared over r, so the 0.789 gets divided by 0.10, that's equal to 8.79 meters per second squared. Same as the answers the first. So through this, we can gladly verify that the correct answer is 8.79 meters per second squared. Now, the last problem is pretty simple. A uniform sphere with a uniform sphere with a mass of 25.5 kilograms and radius of 0.38 meters is rotating at a constant angular velocity about a stationary axis that lies along the diameter of the sphere. If the kinetic energy of the sphere is 158 joules, what is the tangential velocity of the point on the rim of the sphere? So we're trying to find tangential velocity. And we're given kinetic energy is 158 joules, mass is 25.5 kilograms, and radius is 0.38 meters. So the inertia of a solid sphere is 2/5 mass times radius squared. So we're trying to find volume. Not volume. We're trying to find tangential velocity, which is equal to r times angular velocity. Now, kinetic energy rolling is simply 1/2 I inertia times angular velocity squared. Now we know that angular velocity is equals to tangential velocity times r. So what we can do is simply plug that in. 1/2 2/5 nr squared is equals to angular velocity squared. Since we have to use these equations to get the answer we're trying to find. So what we do here is 1/2 times 2/5 mr squared times angular velocity squared. If you plug that in, that would be 158 is equals to 1/2 times 2/5, 25 point times 25.5 times 0.38 squared times final angular velocity squared, that's 158 is equals to 0.736 angular velocity squared. So divide both sides by 0.736 to get angular velocity squared, and to get angular velocity, you square root it. So it becomes 14.65. Now tangential velocity is simply angular velocity times the radius, which is 0.38 meters. So once you plug that in, you get the tangential velocity, which is 5.57 meters per second squared. And those are the 3 problems that I'm gonna present for today. If you learned something, again, please like and subscribe because I really need it, man. See ya.